Today we are excited to present our project titled Smart IoT-Based Air Quality Monitoring and Pollution Management. So air pollution is one of the most pressing issues of our time. It affects on public health from respiratory disease to cardiovascular complication are well documented. Beyond its health impact, pollution also significantly contributes to environmental challenges like global warming and climate change. The question we face is how can we effectively monitor air quality in real time and use that information to make informed decisions. So that's where our project comes in. Our goal is to create a system that not only monitors air quality but also predicts future trends, helping individuals and policymakers take timely and effective action. So the first question you will have is why is this project needed? So in today's urbanized world, air pollution levels fluctuate rapidly due to factors such as vehicular emission, industrial activities, and even weather changes. However, most people remain unaware of this fluctuation until they feel their effect. To address this gap, we developed an IoT-based air quality monitoring system. This system provides real-time data on air quality and temperature, empowering communities to stay informed. But we did not stop there. By incorporating machine learning, we are also able to predict pollution levels for the next 24 hours, making our system proactive rather than just reactive. So our approach is divided into two main phases. So the first phase is data collection. We used IoT technology to collect air quality and temperature data over a 24-hour period using sensor connected to cloud ThinkSpeak. This is a cloud-based IoT analytics platform. So the next phase is data prediction. We applied a machine learning model to the collected data to predict air quality levels for the next 24 hours. This predictive capability helps anticipate pollution trends and provide proactive alerts to minimize potential hazards. Now let me explain how we collected this data using sensors. So to monitor environmental parameters, we use two sensors. First one is MQ135 air quality sensor. This sensor detects harmful gases like carbon dioxide, ammonia, and benzene in the air. It gives output data in terms of ppm, that is parts per million, which is an essential indicator of air quality. Lower ppm value indicates clean air, while higher values suggest pollution. The second one is LM35 temperature sensor. So this sensor measures the temperature, which is a key factor influencing air quality. The LM35 gives a voltage proportional to the temperature, which is converted into degrees Celsius by the microcontroller. So by combining these sensors with IoT and machine learning, our system not only monitors but also predicts air quality levels. This ensures that individuals, communities, and even authorities can act proactively to mitigate pollution risk. Now, my teammates will take you through the system's detailed implementation, data analysis, and prediction results.
So now I will explain the functionality of this system. So this system uses the LM35 temperature sensor to measure the ambient temperature in degrees Celsius. The LM35 gives a voltage proportional to the temperature, which is read by the ESP8266 microcontroller, and it is converted to Celsius reading and displayed in the real time. For air quality monitoring, we used MQ135 air quality sensor. This sensor measures the concentration of harmful gases in the air and gives the data in terms of parts per million. The system interprets this value to assess the quality of surrounding air, by which it provides a quick and effective way to detect the environmental pollutants. And then to ensure user awareness, the system provides visual and audio alerts based on the air quality level. When the air quality is normal, a green LED lights up, indicating the safe conditions. And if the air quality degrades to a medium level, the system activates a red LED signaling the caution. And in case of dangerous air quality, both red LED and a buzzer are activated to alert nearby individuals of the hazardous conditions. This ensures immediate attention to potential risk in the environment. And moreover, the system features a 16 cross 2 LCD display to show the real-time data. So on the first row, the temperature is displayed in degrees Celsius with 1 decimal precision along with the degree symbol. On the second row, the air quality index in ppm will be displayed. accompanied by the textual description of the air quality such as normal, medium, or danger. This user-friendly interface makes it easy for anyone to understand the environmental conditions at a glance. And the next step is to send data to the cloud. So, to enable remote monitoring, the system connects to the internet using ESP8266 Wi-Fi capabilities. It sends both the temperature and the air quality index data to the ThinkSpeak server. So this ThinkSpeak server is a cloud platform for the IoT applications which allows users to log and analyze the data remotely. With this feature, users can monitor environmental conditions from anywhere in the world using a web interface, making the system an effective solution for the real-time environmental monitoring. So this project combines temperature and air quality monitoring, real-time feedback through LEDs and buzzer, user-friendly data display, and IoT-based remote monitoring. So this is the ESP8266 code using which we have developed this system. Now my another teammate will explain the further functionalities of the system.
So, as we have seen the 8266 program and the components used in the physical project, let us now move to the service and other machine learning models used for this project. So, this graph depicts the temperature sensor reading throughout a day, and this particular graph depicts a data recorded from 5:50 p.m. to 8:05 p.m., which depicts the temperature. And then in the next graph, we can see the readings of the air quality, which is shown in parts per million, which is also recorded during the same time from 5:50 p.m. to 8:05 p.m. So these are the data that we have got from ThinkSpeak. So ThinkSpeak is a cloud-based IoT analytics platform that plays a vital role in our project. So we have did a real-time data collection and storage from this, which is taken from ESP8266 microcontroller. So ThinkSpeak stores this data securely in the cloud, ensuring we have continuous access to it. So ThinkSpeak also provides a powerful visualization tool that allows us to analyze trends in air quality and temperature using interactive graphs that we have seen now. And its lightweight, especially efficiency, is pretty good for IoT applications and eliminates the need for setting up and maintaining a separate server. Once we have collected all these data, we can now proceed to training the machine learning model for this system. So the second most important key of this project is long short-term memory model, which is also abbreviated as LSTM, which is a specialized neural network architecture designed for time series forecasting, which we are doing in our case. This model allows us to predict air quality trends for the next 24 hours by training the data of the previous or the current 24 hours data, which we have done in this case. So initially we have prepared the data for this model, which is through the ThinkSpeak. We have taken all the 24 hours data, that is the temperature and the air quality index. And then next one, we'll be training the data set, training the model using the data set. And then we will be building a AI model, which will train on the previous data and predict the next upcoming data. So what we have done is we have given the AI model the last 24 hours air quality index, that is in terms of temperature readings and the quality in ppm, and then this model will train upon the data set, and then we can get next 24 hours data through this AI model. So we have implemented that using the Python, and this is the graph where the red color line shows the previous recorded 24 hours data which we have taken through ThinkSpeak IoT service. And then the blue color line depicts the upcoming 24 hours, that is the next 24 hours data that we have gotten from the Python AI model that we have trained. So we are feeding this Python model the 24 hours data that we have recorded using the ESP8266 microcontroller, and then we are getting the output in terms of the next 24 hours air quality index readings. So by combining ThinkSpeak IoT service for real-time data collection and LSTM for prediction of the next upcoming data, we have created a system that not only monitors air quality but also anticipates and predicts the future changes, which will be really helpful. This capability empowers us to take proactive measures, making sure a system is powerful enough to proceed for pollution control. So now we'll attach the hardware demonstration of this system in the upcoming section.
So the connection is establishing and the sensors are reading the data, and we can see the display for temperature and air quality index. We see that the LED is blinking green, so the air quality index is normal. And if we would have gotten an abnormal readings for the air quality index, the buzzer would have sounded. Thank you.